Hey guys, and welcome back. In this video we're gonna go over the SkipDraw design pattern, so stick around for that. Alright, so let's get started. It's the code that we've been using forever. The only thing I did is set the control playfield, the playfield to be reflected instead of copied. And I added over here some values for our player and for our playfield. So let me go back over here. And like I said, we're gonna go over the SkipDraw really fast. But before that, we're gonna go over our reference material over here, which is our Atari 2600 Programming for Newbies by Andrew Davey. And we're gonna go over by the same order, and we're gonna go first thing for a loop before we go to the SkipDraw right down here. This is the part, which is part of the two-line kernel. So let's go over the loop, and like I said, plenty of time. I'm just using the repeat because I thought there was either to demonstrate or our material at the time, but now we're gonna use an actual loop because when you make a game, you're gonna need a loop. So this is gonna be our counter. And if you go over the 6502 tutorials, it's pretty much, I think I did a simple loop. So we're gonna give it a label. We're gonna call it main. A lot of people like to call this a kernel or something. I like to call it main. And we're gonna increment x. We're gonna compare x to the value 192, since there's 192 scan lines. And y is not 0, branch to main. So as soon as the x register gets to 192, it becomes 0. And then we get out of the loop. So here it is, as expected. And just to demonstrate as well, one of the problems not a problem. Oh, it is a problem. That's why the two-line kernel is kind of a design pattern, because we choose solve some of the issues that we have. But let's load our playfield data. So playfield data 0 of x, and store that into playfield 0. So let's load and store playfield 1 and 2. Here it is. And if I were to assemble, here it is, my alien that I drew. It's upside down, simply because that's the standard. And you're wondering why it's upside down, because let's go over here, and let's go over the amount of clock cycles that we have over here. We have 2, 6, 9, 13. I was right over here, 31 cycles out of 76 cycles. So, well, let's see, 9, 13, 16, 20, 23. So right over here, that's our cutoff. So we were good enough just to start all the playfield before the TIA start displaying, which is well, it's not bad. And as you notice over here, still the start, then that's 3 more for the new line, then increment 2, and so forth. But there's a better way to do this, which is if you were to decrement it. So let's, instead of increment, that's decrement x. And as you notice, it just took out this compare value over here, and we saved ourselves 2 clock cycles. And it says right over here, those 2 clock cycles is 2.6% of our time that we have, which is a lot. I know it seems like a kind of a premature optimization, but it's pretty much the standard, and it works fine. The only difference it is, let me run this. Oh, of course, it has set you 192 and then the increment. There it is. There is my angry alien over here with earrings, maybe. I don't know. So that's what I have over here. And just because of that, instead of 31 or 30, it's 3 if you jump the page rebound. Instead of 30, we have 28, which is pretty good. But we still need to add a player, unless you have your game is only a playfield. But now we need to add a player. So let's load a with player. Player 0 X. Store that you. So this is 4 and 3, so 31 to 30, so it's 38 to 36, which is. And if we run, there's an error over here. What's the error? GBR0. No, it's graphics player 0. And there it is. This is my sprite, or player sprite. As you've seen over here, it's just going over since it's 192. So it goes over here, and then over here, and then over here. It's going all over the place. And let's go over here. That's where we are. That's 4 and 7. So we still have a lot, but as you notice over here, let's say I want a player 0 or 1. Depending on the kind of game you have, you could manually set to 0 to 1. So here is 0 and so let me just load a with 0 here and start this so it doesn't go over the 37 horizontal. Here it is. Just stop it over there. Okay. Let's give space. So like I was saying, you could manually set this to 0 or 1. Depending on the game, you could do that. But there's a better way to do this, and that is with the Y index. And to do that, we actually gonna need a segment. You're gonna need a variable, and all the variables are RAM is on location 80. And let's call this sprite pointer. And then you can either save to or DSW, so word or 1. I'm gonna do that. With some space to look at pretty. And we can do this instead. We can parentheses. Oops. Like this. Then you want sprite pointer. And then Y. Well, the Y is the only one that's able to do this, so we have to change this from X to Y. So this is gonna be Y. Y, Y, and decrement Y. Oh, excuse me. And here's our sprite pointer. A pointer, if you came from a C++ or a higher programming language, is just a memory location that points to memory. We don't have to worry about it because our instruction actually is going to convert the mnemonic to the right opcode to handle this. And after Remand 6502 video, I'm getting this memory location and adding Y to it. But let's load it. Let's load the value. Give me the high value. This is greater than is a high value. Lower than is a low value. Remember that even though 6502 has a 16-bit memory address, so we need to give it a high and low value. So give me for player 0, for example, player 0. Then start that into sprite pointer. We just copy and paste. Sprite pointer. I'm gonna copy this, paste, +1. Give me the low by. Let me assemble over here. come over here. Here it is, F0 and D1. And actually, I don't know what's gonna happen if I revert this. Let me just check this out, see what happens. Oh yeah, remember it is in the reverse order from the 6502 videos. It won't. First is gonna take D1. So right now it's looking at D1 F0. We don't want that. So make sure we have it properly right. So first we start the low and then the high. So that's the perfect one. So this is looking at F0 D1, and let's go to F0 D1. And what do we have over here? Actually, oh, no, not you. Exit menu. F0. This is a jump. Here's a byte, 81. So that right over here should be. So here's F0 D2. It's 81. So here it is. Our sprite right over here. It's pointing for right this location over here, which is perfect. Now let me close this. So now we set this our Y index right over here, and now we could, for whatever part of the game, you can actually change this, and you can manually change from 0 or X right over here. And the benefit of this, let's say for example I have repeat. Let's say there's a bunch of data over here, or it's a really big sprite data for whatever reason. Byte, can even type byte 0. So for example, let's say there's 100 and, well, there's 8 over here. Let's say there's 200 bytes in between this, or it's in different locations for whatever reason. So now if I were to what's doing over here, unsolve repeat. Oh, this should be repeat n. That's the problem right over here. Here it is. So now there's not this giant line missing over here, but now it's easier because, well, like I said, you can set up whatever you feel it's best for you, but this way we can manually, instead of manually setting up player 0, player 1, we can actually at any point change the playfield pointer and change the sprite that we need. So with that set up, here we have our kernel right over here, our main loop, and let's count what you have. 2, 6, 9. This is a 4. Yeah, it's a 4, so it's 13. 13, 16, 20, 23, 28. 28 plus 3 is 31. And there we have a 34 or a sprite. So let me count this one more time. 6, 9, 13, 16, 20, 23. So that's the problem that we have at 23. Then we start the sprite, which is not a well set up design. Maybe it is, maybe it isn't. Maybe there's more space over here, and let's say, for example, your where's my mouse? Oh, there's no mouse over here. Let's say it's just not moving all the way over here, probably from here to here. So then you can cut off, and that wouldn't matter. But that's a design problem, and a design problem can solve the 2-line kernel, but that's not a problem in the next video. But that's not a problem for right now. But we have another problem, if you remember. If I remove these right over here and right over here, let me assemble this. We have this giant line going from our so it's loading all these values from our sprite all the way over here from for player 0, player 1, and then our playfield data as well. So in order to solve that problem, we can use the draw skip method, and we have over here the description. I'm gonna put all these links on the description right below, and this is the original SkipDraw posting right over here. So let's look at this one then, since I already have this open. So here we transfer the line counter, since it's Y, to A. Actually, look, this one, because this is already all the explanations right over here. Then we set our carry, which is really important. Like it says, this can be omitted or avoided if you know what you're doing. If the sec is already on another line or so forth. And then you're gonna subtract that by sprite n. Sprite n is pretty much a location. So we'll have here, right over here, somewhere over here, have lock PS1. This is the location of our sprite. Then instead of sprite n, it's gonna be lock. And let me show you why this sec is important. Let me go over here, our code. Let's see over here. Let's set load A with 10 and subtract with 10. So let me assemble and see what I have. Let me see, where is this sec? Oh, right over here. Run to this part. So let me step. So, oh, where am I? Oh, I'm all the way down here. Run line to here. Okay, step. So set our carry flag. Load the 10 over here. Subtract 10. What do you got? We got 0. As expected, of course. So let's just remove this and show you guys what happened next. And let's run the same thing again. Oh, here it is. So here you have 10. You're gonna subtract 10, and look what happened. You actually almost subtracted by 11, if you will. So it's 255. So that's the problem that we have if you don't have our set carry flag on. So make sure you have it on, because it makes a lot of difference. So let's go back over here. So then you're gonna subtract by the location, and then you're gonna add the sprite height. So the sprite height. The sprite height is pretty much the, like it says, it's the height over here. So if you notice over here is 1, 2, 3, 4, 5, 6, 7, 8. So the sprite height is pretty much 8. And then we have BCX, which branch why the carry is set. And to skip the draw. So skip the draw. And let me go over here. And he also has the illegal opcode method right over here. A bit different. So here you're loading the height of the sprite being 8, and here you're going to decrement by the sprite n over here, it's the location, and then compare that. And then we go to the SkipDraw. So the difference over here is 9 to 11 cycles. This is 9 cycles, and this 11 is just by the sec over here. And here is the exact same thing. Just go into the explanation, and of course I'm gonna put this link on the description when you're done with this. Alright, so I noticed the video is getting a bit too long, so I'm just gonna just go over really fast over here. So set the carry, transfer the scan line to A, and then you're gonna subtract. So the carry is gonna get off as soon as you go negative. There's no other way if you choose. As we're dealing with the subtract with carry. So if it goes negative, then the set is gonna be off, and if it's not off, it's not gonna jump to the draw. And then of course then you have the add with the sprite height. So the only way the carry to be set on this way, if the sprite height somehow, let's say it's 8 and this is 1, it's not going to set a carry, but if it's 2 then it's going to set up a carry as soon as there's a change of this excuse me, this change. So let's choose from 8 to 2, you're going to go over 1 step to the left, so that's a carry, and so forth. So that's the only way this is going to work. So it's all of this either going to skip the draw or it's going to draw. So that's pretty much the idea of it. And like I said, it's getting a bit big, so that's going to be it for this video. In the next video, I'm going to go over, I'm going to use this alongside with the 2-line kernel, and over 2 lines, it's pretty much what small preview. Over 2 lines, all we want to do with 2-line kernels is to update the as much as we can, especially in the first 23 clock cycles where there's nothing to be displayed. So that's the advantage of using the 2-line kernel along with the SkipDraw method. So with all that said, that's gonna be it for this video, and see you guys in the next one. Thank you.